Students, it's the time for delivering the second lecture of linear algebra. The second lecture is about the same topic, introduction to vectors, but the topics are extended. So listen carefully, because this lecture is very important with respect to any examination point of view. There are some hints, some notes. The first one is the dot scalar or inner product of two vectors. What is the dot product of two vectors? Or you may say that scalar product of two vectors or inner product of two vectors. First of all, we will discuss this topic for 2D vectors. 2D vectors mean vectors in two-dimensional plane. If you draw a vector on the whiteboard, so that is a 2D vector. For example, let's say u is a vector whose components are u1 and u2. This is the component of u along x-axis, and that is the component of u along y-axis. Similarly, a second vector v having components v1 along x-axis and v2 along y-axis. So let's say these two be any two vectors. Their dot product or scalar product or inner product is denoted by u dot v. Remember that the dot product of two vectors is denoted by u dot v. There is a dot between these two vectors, so that's why this is called dot product. Secondly, it is also called scalar product because the dot product of two vectors is actually a scalar quantity. It gives only the magnitude of this vector. So their dot product is denoted by u dot v, and that is given by u is actually u1 comma u2. From there, then there is dot between these two vectors, dot. The second vector is v, whose components are v1 v2, that is v1 v2. So the dot product is actually the sum of the product of corresponding components. The sum of the product of corresponding components. What are corresponding components? The first component and the first component of these two vectors are corresponding components. Similarly, u2 and v2 are corresponding components. So that is actually the sum of the product of corresponding components, that is u1 into v1 plus u2 into v2. So that is for 2D vectors. Similarly, if we have got a 3D vector, for example a vector having components u1 u2 u3, these vectors have three components: the component along x-axis, y-axis and z-axis. So these vectors lie actually in space. So let's say you have got these components and we have these components. Then according to that idea, the dot product of these two vectors will be the dot product of these components. So that is u1 v1 plus u2 v2 plus u3 and v3. So that is for 3D vectors. If you write a vector in column notation, we have studied that we can write a vector in a row form. Also this vector can be written in column form, and you can write this vector in ij notation, u1 into I plus u2 into j, and so on and so on. So if the vector is given to you is in column notation, so don't be confused about this notation. That is the same, u dot v is equal to first into first component plus second into second component. So this idea can be extended for 3D vectors. What does it mean? You can write here three components from here: u1, u2, u3, and v1, v2, v3. So the dot will be the same as given by in this B. Now perpendicular vectors. How could you know that two vectors are perpendicular to each other? Two vectors will be perpendicular to each other if the angle between those two vectors is 90 degrees. So we say that these two vectors are perpendicular to each other. So from here, two vectors u and v, are said to be perpendicular if their dot product vanishes. If their dot product is 0, then we say that these two vectors are perpendicular to each other. So remember this statement, that if the dot product of two vectors is 0, then we say that these two vectors will be perpendicular to each other. The third one is if u is a unit vector. For example, a vector which is given to you is a unit vector. What does it mean? That if the length of this vector is 1, then the dot product of this u vector with itself u dot u, so that will be equal to 1. So this is for MCQ's point of view. If u is a unit vector, then the dot product of u with itself will be equal to 1. And the fourth one is the dot product between two unit vectors is between -1 and 1. That is the dot product of u with itself, u dot u. The dot product of unit vector with itself is equal to 1. But if there are two different unit vectors, then the dot product of those two unit vectors is between -1 and 1, including -1 and 1. So that is the fourth note. And you see in this slide there is an example that if you are given two vectors u and v, we see that in this examples u is given in column notation. You can write this vector as 1, 2, -3, or you can write this vector as 1 into I plus 2 into j minus 3 into k, and so on. Secondly, v vector is given to you in 3D 2, 2, 2. So the question is, find the dot product of these two vectors. That is the first part. Secondly, are these vectors perpendicular to each other? That is the question. So first of all, we need to find the dot product of these two vectors. So the dot product of these two vectors is equal to the dot product of their components, just like that, dot, and that will be equal to first multiplied by first plus second multiplied by second plus third multiplied by third, and whenever you calculate this sum, that will be equal to 0. So the dot product of these two vectors is equal to 0. So that is the solution for this first part. Secondly, we are asking about the perpendicularity of these two vectors. So we see here that the dot product of u and v is 0, and we have just studied that if the dot product of two vectors is 0, then they will be perpendicular to each other. If this answer were not, for example, if this answer is not 0, then we say that u and v are not perpendicular to each other. So because the dot product is 0, so we may say that they are perpendicular to each other. That is, the angle between u and v is 90 degrees. Now notes are there, and these notes are for the purpose of MCQs. Don't worry about those things, but MCQs are very important, because there will be 20 marks for you, MCQ section. So be careful. If the dot product of two vectors is greater than 0, means positive. If you find the dot product of two vectors and that is positive, then the angle between these two vectors will be less than 90 degrees. Less than 90 degrees when the dot product is positive. And whenever the dot product is negative, then the angle between them will be greater than 90 degrees. So you may say that the angle between two vectors will be greater than 90 degrees if the dot product is less than 0, and the angle between those two vectors will be less than 90 degrees if the dot product is positive. And the third note is any 2D unit vector. 2D, that is the first thing, and unit, that is the second thing. 2D unit vector. So 2D unit vector can be written as u cap. We have studied that unit vector is denoted by putting a cap on a letter. So that is a unit vector, u cap. U cap can be written as, u cap is actually what? A 2D unit vector will be equal to cos theta comma sin theta, where theta is the angle between those between unit vectors and the x-axis. That is the figure. Just look at this. We have studied that I is a unit vector in the direction of x-axis, so I can be written as 1 0. That is 2D form of I. If that is 3D form, so that will be 1 0 0. So I is the unit vector in the direction of x-axis, and this is actually a unit vector u, and this unit vector is making angle theta with x-axis, this theta. So whenever a unit vector makes an angle theta with x-axis in the positive direction, anti-clockwise direction, then that unit vector will be written as cos of this angle, sine of this angle. So for example, if this angle is 30 degrees, so this vector will be written as, and this vector is actually a 2D unit vector, this vector will be written as cos of 30 degrees sine of 30 degrees. If this angle is of 45 degrees, then this unit vector will be written as cos of 45 degrees sine of 45 degrees, and so on. If you look at this vector, unit vector I, which is a unit vector in the direction of x-axis, we know that this unit vector I makes an angle of 0 degrees with itself, with the x-axis. This vector, this unit vector makes an angle of 0 degrees with the x-axis. So I will be written as cos of 0 degrees. This is actually cos of 0 degrees, and we know that cos of 0 is 1, so that is why this is 1, and this is actually sine theta. This 0 is actually sine theta, and theta in this sense is 0, so that will be sine 0, and we know that sine 0 is 0. So that is the idea for a unit vector when angle between x-axis and a unit vector is given to you people. So that is the second slide, and the third slide we will be studying here the length, or you may say that norm, or you may say that magnitude. These three are the names of one person: length, norm, or magnitude of a vector. So what is the magnitude of a vector? That is actually the length of that vector. For example, you are given a vector in 2D plane, u is equal to u1 u2 is a 2D vector. Then the length of this vector will be obtained, will be denoted by absolute u, modulus of u, because length is always positive. So that's why we denote length of a vector by the magnitude of u. So the magnitude of u, the magnitude of this vector will be obtained by the square root of the sum of the squares of the components. Square root of the sum of the squares of those components is the length of a vector. That is the square root of u1 square plus u2 square. For 3D vector, if you are given 3D vector whose components are u1, u2, u3, so its magnitude or norm or length will be equal to square root of u1 square plus u2 square plus u3 square. So that is very simple to obtain. And the other one is if you want to find a unit vector in the direction of any vector u, if you want to find a unit vector in the direction of this u vector, unit vector in the direction of this u vector will be given by u cap. U cap is actually unit vector. So u cap will be equal to this vector which is given to you, this vector divided by its magnitude. So vector divided by its magnitude is actually a unit vector in the direction of this vector. Vector divided by its magnitude of the same vector is actually a unit vector in the direction of this vector. And the third one is we have just studied that I cap can be written as 1 0 0. How could we write this 1 0 0? Because we see that the coefficient of I is 1, so this I can be written as 1 into I, and j is missing here, so we write here plus 0 into j because j is missing here, and k is missing here, so we can write this as plus 0 into k cap. So if you remove this I j k, so I can be written as 1 0 0. Similarly, j can be written as 0 1 0, and k cap is 0 0 and 1. And the next one is the cosine of the angle between two vectors. If you are asked to find the cosine of the angle between two vectors, so that is given by the formula. If you are given that theta is the angle between two vectors u and v, then the cosine of this angle, cosine is actually cos of theta. So cos of theta will be obtained by this formula: the dot product of these two given vectors divided by the magnitude of the first vector into the magnitude of the second vector. So remember that the cosine of the angle between any two vectors is obtained by this formula, that is the dot product of the two given vectors divided by the magnitude of those two vectors. And the other one is Schwarz inequality. What is Schwarz inequality? That it says that the magnitude of the dot product of two vectors, the magnitude of the dot product of two vectors is always less than or equal to the product of the magnitudes of those two vectors. I mean, if you split this magnitude with u and v, so this value will be less than or equal to the separate magnitudes, the product of the separate magnitudes of these two vectors. So this is called Schwarz inequality. And the other one is triangle inequality. And Schwarz inequality, there is dot between u and v, and triangle inequality, there is plus sign between u and v. The inequality remains the same. If there is dot, so we will put here multiplication between these two. If there is sum, so we will put here plus between these two magnitudes. So that is triangle inequality. This example is very important because in this example we will be studying all those topics which are discussed previously in the slides. So in the example, you are given two vectors u and v, and these two vectors are given in the row notation, ordered pair notation, 3 comma 4. U is 3 comma 4. You can add this u as and column vector 3 4. And if you want to write this vector in ij notation, so that is actually 3i plus 4j. Similarly, v can be written in column as 4 3, and in ij notation that is 4i plus 3j. Anyways, you are given two vectors u and v, and you are asked to find the magnitude of this u, and secondly the magnitude of this v, and the third one is the magnitude of the sum of these two vectors. You need to find the sum of u and v and then find its magnitude. And the fourth one is you need to find the dot product of these two vectors. The fifth one is the magnitude of this dot product. Magnitude. Find the dot product of u and v and then its magnitude. And the sixth one is you need to find the cosine of the angle between these two. Cosine of the angle between these two. And the second last one is you need to check the Schwarz inequality. And the last one is you need to check the triangle inequality. Sorry, that is not the last one. That was the second last one. This is the second last one, and that is the last one. And the second last, you need to find the unit vector in the direction of u. In the direction of this u, you need to find a unit vector. And the last one is you need to find the unit vector in the direction of this v. So let us start the answer. You need to find the magnitude of this u. So the magnitude of this u is equal to square root of first component square plus second component square. Now calculate this sum and this square root, so that is 5. So the magnitude or the norm of this u vector is obtained, which is 5. Secondly, you need to find the magnitude of this v vector. So the magnitude of this v vector is equal to square root of 4 square plus 3 square. Calculate this sum, and now this square root, you will get 5. So the magnitude of v is again 5. So that is the answer for the second question, the second part actually. The third part is you need to find the sum of u and v and then its magnitude. So first of all, you need to find the sum of these two vectors. How could you find the sum of two vectors? That is actually the sum of corresponding components. which is being studied in the last lecture, that if you want to find the sum of two vectors, that is actually the resultant of these two vectors, so that will be equal to the sum of first components comma the sum of second components. So that is the sum of those two vectors. But we need to find the magnitude of u plus v. So the magnitude of u plus v will be equal to square root of first component square plus second component square. So that is the magnitude of u plus v. You can simplify this square root of 98 by calculating it on by the calculator. The d part is you need to find the dot product of u and v. How could you find the dot product of u and v? That is studied in the previous slide in this lecture. So this equal to first component into first component plus second component into second component. So calculate this sum to get the dot product of u dot v. And e part, you need to calculate the magnitude of u dot v. So just look at this thing, u dot v is actually a real number. That is a number, a scalar quantity. So the magnitude of u dot v is actually the magnitude of 24, and the magnitude of 24 is the same 24. Or you may write this as square root of 24 square. So square root of 24 square is actually the same 24. So the magnitude of a real number is actually a positive real number. If this were negative, then the magnitude of minus 24 will be plus 24. Remember that. So that is the magnitude of u dot v. And in this part, f part, we need to calculate the cosine of the angle cos theta, and we know that cos theta is equal to the dot product of the two given vectors divided by the product of the magnitudes of these two vectors. That is the formula for cos theta, which is being studied in the previous slide in this lecture. Now we have already calculated u dot v. U dot v is 24. So replace u dot v by 24. We have calculated the magnitude of u, which is 5. That is from a part 5, and we have calculated the magnitude of v, which is 5, and that is actually the second part b, that is 5. So replacing all these values, we will get cos theta is equal to 24 by 25. So that is cos of theta. And g part, we'll check Schwarz inequality. So this is actually Schwarz inequality. The magnitude of u dot v is less than or equal to magnitude of u into magnitude of v. So if you look at part E, we have calculated magnitude of u dot v, which is 24. So from part E, the magnitude of u dot v is 24, and for this right hand side, we need magnitude of u and magnitude of v. If you look at this a and b parts, these a and b parts, we see here that the magnitude of u is 5 and the magnitude of v is 5. So from part number a and part number b, their product, magnitude of v into magnitude of v, is equal to magnitude of u is 5 and magnitude of v is 5. So 5 into 5 is 25. Now compare these two values. We see here that 24 is smaller than 25. 24 is less than 25. So it means that, but 24 is u magnitude of u dot v. So magnitude of u dot v will be less than this 25, which is actually the product of the magnitudes of u and v. So that is proved. Schwarz inequality has been proved here. There is equality sign, so these two will be equal if the angle between these two vectors is 0 degrees or 180 degrees. Anyways, that is the proof of Schwarz inequality. H part is we need to check the triangle inequality. So this is triangle inequality. From part C we see that the magnitude of u plus v is square root of 98. So that is the square root of 98, and the square root of 98 is 9.9. And for this right hand side, the sum of the magnitudes of u and v, so that is from part A and part B. The magnitude of u, which is 5, and the magnitude of v, which is 5. So the sum of these two magnitudes is equal to 5 plus 5, which is equal to 10. Now if you look here, 9.9 is less than 10. 9.9 is less than 10. It means that absolute of u plus v is less than the sum of the absolutes of these two vectors. So that is actually Schwarz triangle inequality. Part number I asks us to find a unit vector in the direction of u. We have studied in the previous slide in this lecture that how could you find a unit vector in the direction of a vector. So unit vector in the direction of u is actually u cap, and u cap will be obtained by dividing this u vector by its magnitude, and this u vector is given to u 3, 4. So 3, 4 divided by its magnitude, the magnitude of u from A part is 5, so divided by 5. Now divide this 5 by 3 as well as by 4, so that is the unit vector in the direction of u. Similarly, unit vector in the direction of v will be obtained by dividing this v vector by its magnitude, and we see here that v vector is 4, 3. So this v vector is 4, 3 divided by its magnitude, and the magnitude of v from part B, that is 5. So that is the unit vector in the direction of v. So all those topics are covered in this example.